Routing. What it really means, routing. Routing is defining the path. Please understand. Routing is not moving the packet. It is not moving the packet. Routing is defining the path. On every router, there should be routes for all destination. Only then router can route the packet. Meaning, we have something called a routing table on a router. Routing table. The table will have all the remote destination network information and the path to take in order to reach those destinations. For example, let's say you have a router here and you got 4 links. And let's say this is LAN. You are connected to 3 different ISPs or 3 different network. It doesn't need to be an ISP. So from LAN, you want to reach someone in the remote. See, I have drawn like a cloud because, it need not to be one single router, maybe many routers, many autonomous systems. There is a network called 20. Let's say you have a computer 20.0.0.1. And you got a computer here, 30.0.0.1. You got a computer here, 40.0.0.1. And this is 10.0.0.1. Now, if this 10.0.0.1 computer in your office, if it needs to ping any of these, this router, let me call it as router A. This router A should have route information, route information, path information in the routing table. So in the routing table, it should have a path. For example, this interface, this port name is F00. F stands for Fast Ethernet. F0/1. 0 means 0th slot. 0th slot, 0th port. 0th slot, first port. F0/2. 0 slot, 0th slot, second port. Let's say this one is Gig Ethernet. G0. Gig Ethernet is faster than Fast Ethernet. Gig Ethernet is 1000 meg per second. Fast Ethernet is 100 meg per second. So Fast Ethernet is faster than Ethernet. Simply Ethernet is only 10 meg per second. Fast Ethernet is faster than Ethernet. Gig Ethernet is faster than Fast Ethernet. So that's not our topic today. Now this computer A, I'll call this as A. If this computer A needs to talk to 20.1, the router should have a route saying 20 network. You need to send it out via F00. 30 network. You need to send it out via F0/1. 40 network. You need to, any traffic that goes to 40 network needs to be sent via F0/2. 10 network. G0. So this is what we call it as routing table. The table which has got information about the destination and the port on which the traffic should be sent out. So the routing table needs to be updated. Only an updated routing table can move the packet. Even if you give $1 million rupee and buy a router, if the router don't have route, path in the routing table, it cannot route the packet. Whether it is small 1 rupee router or 1 million rupee router, both need route. Both need route in the routing table. Route, both are same, okay? These Americans call routing table, route. Indians, the Asians call routing table. But mostly people will say only routing table. They won't say route, they will say route. So which route I should go to Himalayan mountain? That's how Indian will ask. Which route should I go? Which route I should take is what the Western people will ask. Which route I should take to reach Himalaya? So networking world, we speak in the slang of Western people. So they say route, path, simply means path. Avoid confusion. Let's say path. So this path information will not come just like that, boom, like that. You have to do something for these routers to get these information in the routing table. So unless you do some configuration, the routes cannot be updated to the routing table. So that is to make you clear that routers are not supernatural. Routers need your help to learn the topology, to learn the network. Once the router has got route in the routing table, packets can be forwarded. Now, coming back to the original topic of the day, routing. What did I say routing means? Defining. See, this routing table has got these paths because it has been defined by you or by a protocol which is enabled by you. Repeating again. Routing is defining a path so that a router can forward the packet towards the direction in which the destination is located. Defining the path can be done in two ways. One, static routing. Static way. Statically, you provide the route information like I have written here with a pen and the ink. You can also type with your keyboard and say this is the route you need to take. You can statically write routes into the routing table of the router, or you can depend on a routing protocol so that dynamically routes can be updated to the table. So what I'm coming to say here is there are two ways in which the routers get route information in its table. One, you can define it statically. You don't need a protocol. You can define it statically. Going to each router, typing the route statically. The other way, you simply enable a routing protocol, and the routing protocol will discover the routes, and the routing table gets updated with the dynamic discovery of routes by the dynamic routing protocol. So defining route to the routing to the router is what routing. Defining the route, defining the path information to the router is what routing is. This defining the path can be done in two ways. One is static routing, the other one is dynamic routing. Static routing, you type all the routes manually, whereas in the dynamic routing protocol, you use any one of this below protocol. You use one of this below protocol so that this protocol will update the routes for you. We call these as dynamic routing protocol. Dynamic routing protocol. In olden days, see, this is my imagination. It may be true. In olden days, they drew the map of India. How? See, today you got a world map. On those days, no satellite, no computers. And the world map shows India map. This is how India map looks like. Who drew it? From where they saw the whole picture of the India? Did they went on the top of the heaven and see how the shape of India looks like? No. Imaginary lines. This is not real map of India. This is fake. No map is true. All are funny stories. They're not real map of India. No one till today have got the real map of India. Yeah, so far no one has drawn the map of India accurately. That's not true. So they might have traveled like 10 kilometers, and Pakistani might have said, "Hey, this is my okay, fine, that is your place, fine. Let us put a line here." Okay, and then keep going. No one objected. Okay, this is India. No one objected. Keep going, keep going, keep going. Okay, Afghanis are object. Oh, this is Afghani border. Okay, let's put one line. India border is okay. And keep going. Chinese are don't come here. Okay, fine, no problem. That's your place. This is my place. Oh, they put one line there. This is how they might have drawn the India map. That is how they might have made the borders. Because on those days, no computers, no Google map, nothing. It was human being. They walk, 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 walk. Maybe the horse ride. They go in horse, and they take a nap. They sleep, and then they eat, and then they go a little more distance, and they draw the map. And at last they come up with one map. And if they say this is the map of India, you have to trust because there is no proof to check whether it is accurate or not. There is no proof. But today it is not like that. Today, if you take your cell phone and you walk through a forest, Google will draw a road automatically. Who is drawing the road for you in the map? Google is drawing the road today. Kiran started from this place. Earlier he said this is his house. From his house, he has gone to that place. From his house to the railway station, he has taken this shortcut. Earlier, it was not at all a road there. But because you went in that small jungle road, Google thinks that it's a road. Now Google start drawing a line between your house and the railway station through the jungle, a road. And now someone like me comes, I, I, I landed in the railway station and I want to come to your home. And I check Google and it shows through the jungle. Because earlier you came through the jungle. That time there was no road in Google. But because you took your cell phone and you are walking from your house through the jungle shortcut to railway station, Google thinks there is a road there. And it is saved it. It has saved it. So when someone tries to come to the same destination, it shows the road. Okay, there is one road you can go now. You can go by walk. That is what dynamic routing protocol. Dynamic routing protocol, the same like Google Map. When a new advertisement comes from a direction, when a new advertisement about a network comes from a direction, it will draw a line saying, oh, that 20 network advertisement was coming from this side. So 20 is in this direction. Dynamically, it will write the route into the routing table. You don't need to write the route. You just enable the protocol on all the routers. All the router will start saying, I'm connected to this, I'm connected to that. And everyone will be keep on advertising it. And the others will be learning those networks from the others. Dynamic routing, static routing. Which one is good? Both are good. In a large environment, like drawing an India map, you cannot do statically like in ancient days because those maps are not accurate. You will not be able to get an accurate map if you do statically. You may say, okay, 1,000 people assignment in 1 month. We need to draw an Indian map. Let us all go to the borders and see and draw the map. Not going to work because India is very large. It is not like a Dubai. Dubai is just small city, which is like Bangalore city. The entire Dubai is only the size of Bangalore. That you can draw. That also you cannot do manually. It may not be accurate, but to an extent you can do it. But big country India, you cannot draw statically. So you use satellites. We use satellite. We use the pictures from satellite, and then we decide whether this picture is showing the borders of India or borders of Pakistan, where the borders are. You try to draw and develop a picture. So now you can give a better map from the satellite because you have eagle vision, like an eagle flying up in the sky and seeing an object down. You're seeing the entire India from the top. You can have a not very accurate, to an extent accurate map. To an extent, you can say this is the total surface area of India. Then also you cannot give the accurate how many square feet India has got. Those are all funny stories. Those are all not true. But still, to an extent, better than static. So when it comes to a large network, you depend on a dynamic routing protocol. For a small network, say for example your house. You can easily draw the map of your house. How much square feet? Take a tape. You don't need a surveyor to do survey. You can do manually. Take someone's help. Measure the area, length, breadth, depth, and then you can say, okay, this is my total area of my house. So for small area, you can use the tape and you can start measuring. You don't need any other advanced device. Likewise, for a small network, like a small company, maybe 10 network or 20 network maximum, you can do statically. You will not have too many routers in a small network. In a large network, we depend on a protocol to do that. Yep. So you can use any one of this routing method, static routing or dynamic routing, or you can have both also mixed together. Wherever you want a clear vision of how the packet is going, you can write static route. You see, you want packet only to go via this way. Then you need to write statically, because if you allow routing protocol, it may take some other path also. According to routing protocol, there may be another best path. So if you have a policy of sending a path to a particular packet via a particular path, routing protocol may not always pick the same path that you want. It may try to give you another path. So if you have a policy in path selection, then you can go with static routing. If you have something like, I don't care what policies, or I don't care what path it will take, I want the best path to be taken, then you can depend on any one of this protocol. I want the best path to be taken, then you will depend on the routing protocol. But if you say, no, on the way I need to go and buy ice cream. So if I depend on Google Map, it will take through some way where ice cream I cannot buy. Then you off the Google Map and you drive your own wish, statically go to the ice cream parlor, eat the ice cream, and take the route to your destination. So if you have a policy like, before going to the destination, I need to go to the ice cream parlor to eat ice cream, then you should not use Google Map. Because Google Map will show you the shortest path, not via the ice cream parlor, it may be via some other path. So if you have a customized policy in path selection, then you need to write static route. Likewise, networking, if you have a very clear policy saying, I want the packet to go only the way this way, only via this way, then you have to write static route. If you say, no, I don't want to write statically, I want a protocol to decide the best path for me, accurate path for me, then you can simply enable one of this protocol. Now, what I have explained so far is what is routing and types of routing. Did you get the point? All right. Now, I'm going to teach you the logic in routing. Yeah, routing logic. What is the logic behind routing? You see, if you have many routers, and let's say you got a network here 1.1.1.1. If someone is pinging from this computer someone is pinging 1.1.1.1. The traffic will go to this router because this is the gateway for this computer. This router's address will be the gateway address of this computer, which we learned early long back. Now, what this router will do, it will send to this R2 via this link. That's all. R1's job is over. Please understand my words. R1 will not worry about R3, R4, R5, R6. It will not worry about those things. R1 will say, okay, you want to go 1111. I don't know where is 1111. Let me send you to the next router. In this router also you'll say, okay, 1111, I don't have it directly connected, so I'll send you to R3. Now you need to go to R3 and write another static route saying, if you don't know where is 1111, send it via this link to R4. You understand what I'm saying? When packet comes to R4, 1111, R4 also don't know about 1111. So you write a static route saying, you can also enable a routing protocol. So what routing protocol or static route will point? It will point towards R5. Because I'm not having 1111 directly connected, I'll send it to R5. R5 checks whether it is directly connected. No, it will send it to R6. R6 will check whether 1111 is connected. Yes, it is connected, so it delivers. So the logic is, any network this router don't know, it should simply send it to next router. That's all. It should not worry about whether next router will know it or not. For router 1, router 2 is the gateway. For router 2, router 3 is the gateway. At last, it reaches the destination. So when you write static route, you should not worry about router 6. When you are configuring static route on R1, router 1, you should simply send the packet to R2. That's all. R1 job is over. R1 job is not to go to R6 and deliver the packet. R1 will send it to R2. That's all. R2 will send it to R3. R3 will send it to 4. R4 will send to 5. R5 will send to 6. If R6 have got the destination, it will deliver. Otherwise, it will send to R7. This is how the routing happens. I can call it as routing logic. This is the logic behind routing. If I don't know, I'll send it to the next router. So the packet will be sent to next router till it reaches the destination. So we have to write a route so that R1 will forward it to R2. And R2 we need to write again a static route so that it will go to R3. Or you can also enable a routing protocol so that route will be dynamically written into the routing table. Yeah. So this is routing. Routing is just instructing the router via which port or to which router the packet needs to go if it wants to go to some destination. That can be done statically or by using dynamic routing protocol. So these dynamic routing protocols have got names like RIP. RIP stands for Routing Information Protocol. RIP stands for what? Routing Information Protocol. Routing Information Protocol. EIGRP stands for Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol. What does OSPF stands for? Open Shortest Path First. Open Shortest Path First. Open Shortest Path First. OSPF. ISIS. Intermediate system to intermediate system. Intermediate system to intermediate system. That is ISIS. Next is BGP. Border Gateway Protocol. Border Gateway Protocol. Border Gateway Protocol. So in this CCNA course, we will be learning static route, and under dynamic routing protocol, we will be learning RIP, EIGRP, and OSPF. Again, to a CCNA level, right? These things will come only when we go to next levels like NP and IE. Fine. So what we are going to learn next is we need to understand the Cisco's environment. I've just given you what is routing introduction, but I cannot go and write a static route if I don't know the Cisco's routing operating system, the router's operating system. We call it a Cisco IOS. Cisco IOS. Have you done anything on Cisco IOS before? Like setting password? No, right? So first of all, we have to learn Cisco IOS. So that is what our next topic is, Cisco IOS. After we learn how to configure a router and a switch, then we will go and test this static route. After followed by, we will be learning routing protocols one by one, right? So any question on what we covered today? We covered routing and routing logic and the names of the routing protocol, no doubt. And see